We're going to look at 3 different styles of cutter block and cutters that go in them. This one being a more traditional style. It's a cutter block that has a wedge bar and a high-speed steel cutter. And we're going to have a look at how we would look at setting these up in a thicknesser. This machine actually is a combined surface planer or jointer and a thicknesser or planer, as the Americans would call it. So the setup procedure when it's a surfacer and a thickness planer, normally we'd set up the cutters from the outfeed table. But if you have a pure standalone thicknesser, then you don't have infeed and outfeed tables. All you would have over the top of the thicknesser block and the feed rollers would be a cover, which would either unbolt or would literally hinge out of the way to expose the cutter block for you to get him set up. So looking at how we'd set up a cutter block purely for a thickness or a panel planer, we wouldn't have any reference points from surfacing tables. Everything is generally set up from the block itself. For this style of block, if it was a thickness planer, normally for a new machine you would be supplied with a crab or spider setting jig. And what that is basically a pair of bars connected by 2 milled ends, and they have a milled out section that basically sits onto the block, and the knives are pushed up against the bottom milled surface to get the knife in the correct position parallel to the cutter block. This planer here doesn't have one of those jigs because, again, I say it's actually would be set up off the surfacing outfeed table. Most planers as a thicknesser would come with one of these setting jigs. This planer has actually springs which would be underneath the high-speed steel blade. So if I look at this is a blade actually out of another machine. Generally we have a high-speed steel blade which has been ground with a clearance angle on the back of it, generally 30, 35 or 40 degrees. Those are the 3 general angles people would tend to have them ground at. That would normally then sit against a wedge bar. The wedge bar has nuts. As we tighten the nuts up, the nuts come out and they literally push the wedge bar in, which cramps the blade in there. That is just being held in purely by friction. The wedge bar also, because it's wedge shaped, as the machine is turned on, all the force of the machine, spinning action, is trying to actually push things out. So the wedge bar gets tighter and tighter. But if this wasn't tightened down properly, obviously the blade can slip out, and that's the last thing you want to happen. So we'll probably find that more modern machines have got some other kind of fixing point to hold the blade in. And also other machines may not only have the blades purely on springs, but they may have within the blade some kind of slot somewhere in there, and you almost have a captive screw with a fixed washer on them that you literally do up with a Allen key, a hex wrench or a screwdriver, and as you raise the screw up and down independently each end, it will raise the cutter up independently each end to a set height, normally off that spider jig. One problem you can possibly encounter is that your cutters aren't actually parallel to your thicknesser bed, which is down below. Normally when a manufacturer makes the new machine, they set up the cutter block so it's parallel to the thicknessing table. So when you put in your cutters parallel to the block, everything works out beautifully. But maybe over time, something goes wrong. If you set your cutters up and they're too high out of the one end, as that block spins around, it'll mean that cutter is too low. And you would see if this was our thicknessing bed, we'd be getting smaller timber from this left-hand end and thicker timber from the other end, which means something has gone wrong. 2 ways of addressing that. Either when you set your cutters up, you've now got to make sure that this right-hand end is lower, so it becomes parallel to the bed, or maybe you'd have to reset your thicknesser bed. That could be done possibly with shims. It may be on this 4-column threaded system that you can adjust the threads of this corner, that corner, to actually bring it back up. Or the other way you can do is to literally reset these cutters so they may be out a little bit more, the one end or the other. That's not going to be quite so straightforward if you've got this spider or crab jig that's over there, because they've got predetermined milled surfaces for this cutter to push up against. You could either possibly carefully file away part of that milled surface so it's now slightly higher, which brings the cutter slightly higher as a reference point, but be careful you don't file away all the accuracy they've already put in there. Or maybe you'd buy some aftermarket setting jigs like these. These basically have magnets front and back and a magnet on the center. These magnets basically will sit onto the cutter block, and the center magnet actually connects onto the blade. So you can see this would literally be able to lift the blade up and down as you do micro adjustments. So for this one, if I sit him on there, we're going to make sure if we put these on at the back of the block and then also the front, we put both sets on in the same location. If I have one of these set with the back bar just on the edge of the back of this block, I wouldn't want the other one span down to a different position because it would be referencing off different places. They must be set up in the same position. What we can then do, if these nuts were loosened off, then with the spring would push the blade up against the magnet on this adjuster, and we could drag that blade up and down. So either we'd want to get these so they're both exactly the same setting, or these might be better actually if we know we've got to get the back one further out than the front one. You know, we can write down the heights these always should be set at for the back and the front. So hopefully then your cutters are matching your thickness of table. The only way to do that is to literally get the machine set up, get everything tightened down, thickness a piece of wood through from the back and the front edge, and actually go and measure them to make sure they're exactly the same. Or certainly for us, we want them within 1/10 of a millimetre. So that's a 250th of an inch. I think that's about 4 thou. So you want really very, very fine tolerances on this thicknessing. You don't want timber thicker one edge than the other. It's going to give you all sorts of problems later on.